and today we're going to learn how to design 4 different types of trusses with MWF. So we're going to learn to do common truss, a ridge truss, valley truss, hip end, and I'll also show you how to assign presets. Assigning presets is kind of a way to add templates to trusses, okay, or to truss envelopes. We will go into our 3D view here, and then we'll go into MWF. So within MWF, in order for us to create a truss, we need to make sure that we create the truss envelopes first. We need an envelope in order for us to be able to build up the members in there. So here you can create trusses using 2 methods. One is a line-based method. This is typically used for more complicated trusses. And then you have your truss profiles options. So in truss profiles, we have a common truss, valley truss. Under hipped, we have a few extra options. We also have a half truss option under truss profiles. You'll notice we also have scissor and split cap options, but these two are not a part of truss profiles because in order for us to create envelopes, we need to use the truss profiles. And in order for us to create a scissor or split cap truss, we need to actually have an existing envelope. So that's why they're not part of truss profiles. They need to be created after an existing envelope has been created. Okay, so in our case, we're going to go ahead and start with our common truss. We'll select this little section here, select the roof. We can go into common, and we can then select main ridgeline. So in the main ridgeline, I'm going to go ahead and select this portion here. Then I have the option for supports. I'm going to go ahead and select this left wall and right wall and hit finish. Here it's asking me within the structural core layer, where do you want that heel edge to align to? So do you want to align it to the far edge? The far edge is basically from this line, from this main ridge line, the farthest away edge of the structural layer. So in this case, it would be the exterior structural core layer face. Or do you want to align it to the center? I'm going to go ahead and align it to the center for this side, and I want to use the same options for the support on the other side. So I want it to be placed on the center for the other side as well. We can go ahead and hit OK. And then here we have a few options for the truss. It will give you a few details about the actual truss. These are not something you can modify. If you want the heel height to be different, just make sure that the distance between the top of your wall and that outer face or the outer face of that ridge line is set up according to your proper heel height. You'll also want to consider offset from outer face when considering your heel height, because let's say if you're using an architectural roof, they probably have added shingles on there. They've probably added insulation, sheathing, and a bunch of other things. So for me to be actually able to place the truss, the top of the truss at the start of the structural layer, I need to make sure my offset from outer face is set up correctly. So I'm going to go ahead and set that to be 2 inches. Oops. I'm going to set that to be 2 inches, and that way it's going to be 2 inches from that outer face down into the truss. Into the roof. For the spacing, I'm going to go ahead and stick with 2 feet for the spacing between my trusses. Because we're creating envelope, that's why it needs to know this information. And then we can go ahead and hit OK. And we'll go ahead and create all of our trusses for us. And now I'm just going to go ahead into level 1 here. And then I'm going to show you what that truss just looks like right now. Let me make that 2 feet. There you go. So here you can actually see that's your 2-inch offset from outer face. And then this is your heel height, and your heel is placed right in the center of the core layer. Okay? Now, if I wanted to make this a split cap or scissor truss, this is where I can come in and do it. I can go ahead and delete that line there. Then I can go ahead and make it a scissor truss. I can choose the elevation. I'll make it 1 foot. And you'll see it will add that 1 foot offset from here and make it a scissor truss. If I undo, I can repeat the same process to do a split cap. I can do a split cap. I can specify the height of the lower truss and the gap between trusses. And over here, I can choose if I want to use a stub cap truss as well. I'm not going to do that. I'm just going to use these settings. Probably leave that to be 6 inches and hit OK. So you'll see it creates that 6-inch gap there based on what we've specified. And it creates 2 separate envelopes. So I can create a separate truss here and a separate truss here. Okay, I'm going to go ahead and undo what I just did, just so that we can create a proper common truss. If I wanted to modify the outline for this, I can go ahead and modify the envelope by going ahead and editing the group, model group. Okay, I'm going to leave it as is just so that we can continue on and see more things. Over here now, I can go ahead and create my girder truss. So for that, I'm going to go to hip and I'm going to go ahead and create a girder truss. I want a girder truss so that I can support all of these members that are going to be added a little later on. So I'm going to choose my supports for this girder truss to be this wall and that wall. Oops, not that one. This one. Hit finish. And I can go ahead and say hip lines. I can choose my hip lines. Since I'm in 3D, I can actually rotate it, select the 2 lines that I want, and hit finish. And then choose where I want it to align to against center line of the structure. And then I can choose if I want multiple girders or a single girder to be created. I'm going to go ahead and create multiples. And then I can choose an offset from hip intersect. I want it to actually be at 0 so that it will actually be located in that exact spot there. If there's already a truss located there, you can probably set this value to be, let's say, 2 feet, for example. You can specify a minimum height for the truss or the shortest truss, and then you can specify your spacing. So again, my spacing is going to be 2 feet. And then on my offset from outer face, I'll set it to 2 inches. And then I'll go ahead and hit OK. And there you go. So it actually created all of my girder trusses for me over here. I probably don't need all of them. I probably will keep only these 2 and then get rid of these so that I can show you how to design a hip end over here. So for the hip end, we can basically either do all of these individually, or we can use the hip end command to actually build those trusses. So we'll use the hip end command. We'll choose our hip lines. Again, I'll rotate it just to select the top of these 2. Make sure if you're selecting the outer face, then always select the 2 lines from the outer face. If you're selecting the inner face, then make sure you select the 2 lines from the inner face. As long as you select the same side, it should be okay. If you don't, then it will error out. So we'll go ahead and say center here. Then for the other side support, we're going to choose again center, hit OK. You can also have like beams and cantilevers as support. So you'll see there's a beam align or a cantilever offset. So you can have a beam as a support, and you can actually choose that beam, and then over here, this option will no longer be grayed out, and you can actually select what face of the beam you want it to align to. Then we'll choose our last truss so that it knows how far it needs to go. Okay, and then over here again, we have a few extra options. You'll be able to see we can't change these values. But over here for spacing, I want the trusses to be every 2 feet. I want it to be 2 feet offset from the hip girder. My minimum height for my truss is 1 foot. And then my offset from face is 2 inches. Then you have something called detailing tolerances and setback tolerances. So detailing tolerances is basically used for your connecting truss. So you'll kind of use the half the size of your connecting truss member. And then your setback offset is used for your current truss, or actually the one that's attaching to it. And it's basically going to be the half the size of your member that you're planning on using for the new trusses that are being created. So I'm going to leave these two at 1 inch each. You can definitely change them and play around with them based on the different sizes you may need to use. You can make it 3 inches, 4 inches, up to you. But I'm going to leave it at 1 inch and see how it places. Okay, we'll hit the OK button here. And you'll see that it actually created every single aspect of this hip end. So it actually created that diagonal there. It's calling it HCG. And then over here we have another one, which is SJ, so side joist. And you can basically play around with the locations if you like, but just be mindful that since these are at a slope, you will actually need to make sure that your offsets are correct. So if you do make a mistake with any of the girder options or any of the hip end options, just undo and redo the envelope. It's easier than manually modifying the model lines. So I was talking about the detailing tolerance and the setbacks tolerance. So the detailing tolerance is from the edge of this point to that line or the connecting truss there. Okay, so whatever member is being placed here, that's that tolerance that you're adding there. And then what the setback tolerance is from that edge to this heel offset or this heel line. And that basically is identifying your member that's being placed for this truss. Okay. We also have an option called auto connections. So we'll select all of these members. And then we want to be able to say that, hey, the weight of this truss is also on you for the girder truss especially. So what we can do is we can go ahead and say supports, and we can say auto truss connections. I can choose what my lateral tolerance and my elevation tolerance is. So if there's a connection within these two tolerances, it will actually place a connector member there. So we'll go ahead and hit OK here. And it says 18 connections were added. So you'll notice that it places all of these little pieces, and basically when I hover over any one of them, you'll kind of see that it's aligning, trying to align itself to the supporting truss, and then the other direction, or the trusses in the other direction, basically are aligned to the shorter edge. Okay, so if I was to come here, you'll see that the longer line is aligned to that supporting truss, and then these two are just connecting or butting up against it. Okay. So once you do that, you can kind of go ahead and build up your envelopes. Before we build up our envelope, we'll actually go ahead and create our valley truss here. So we'll select this. We'll click on valley. We'll select our main ridge line. So I'll rotate it over a little bit. Select that. I'll choose my valley lines. So I'll make sure I'll select the top and the top here. Hit finish. And then I'll select my last truss, which would be this one here. And if I have any supports, I can select those supports. If I don't, I can leave them be. Okay. And then over here, you can choose to place your valley in two ways based on building orientation. If you have wall supports, you can choose that, or you can do ridge intersection. Okay. So wherever it's intersecting with a ridge, it will place it according to that. Ridge here. Then over here, I can basically choose what's my offset from the valley intersect. I can set it to 2 feet, or I can set it to 0. It's up to me. So I typically like to do 2 feet so that it's 2 feet out of here. And then minimum offset from last truss, I'll say 2 feet. And then for the spacing, also, I'll say 2 feet. And then over here for offset from outer face, I'll leave that to 2 inches. And then if you wanted to create a stub truss, you can go ahead and create that. I'm going to go ahead and hit OK here. And you'll see that it creates these little envelopes over here for us to be able to frame there. I can also create a half truss. So if I wanted, I could create a half truss on that side of the roof. Again, same questions. So it asked me for my support and the top edge line. And if I had a girder truss, I could also do place by girder truss. And then you'll notice that disappears, and then you have these two options. Okay, so I'll just say by roof edge, I'll select my edge again. And over here, I'll set my support. Similar options, except now for the spacing, I don't really want it to be 1 foot or 2 feet. I'm going to make it 4 feet apart. And then over here, I can set my offset to be 2 inches. So you'll notice that it actually created all of these, but it did create one at this end. And that's because we have a proper spacing set and we didn't tell it to create one at that location. So I can either create a girder at that location and then treat that as another hip end, or I can individually create each side here to create a proper truss. Okay. So I'm going to go ahead into one of these here. I'll select any one, and then I can go into MWF. And if I wanted to convert this envelope into a truss, I would have to go into our create option here. Okay, and in this create option, I can go ahead and place, I can set up whatever settings I would like. So I can come in here and say, choose my display units. If I wanted to be feet, inches, and 16ths of an inch, I can choose that. If I wanted it to be millimeters, I can use millimeters. The roof category, or sorry, the truss category has automatically selected, so it is automatically selecting roof because we have selected a roof truss. Then you can choose the web type. You want it facing up or down. You can also choose what type of truss you want. I'm going to choose back-to-back for this session, but you can obviously do wall truss or other in-plane trusses, okay, or in-plane extended. So we'll go ahead and use back-to-back trusses. You can give your project a name. Usually if you have if you already have a project name in your properties, it will automatically grab that name. Okay? But since I don't have anything, I actually have to give it a name. Next, we can go into webbing. We can choose our settings here, how we want to orient our diagonals, whether it's in tension, left to right, verticals only, or node only. Whether what is our vertical position? Is it equal, fixed, width, or diagonal? And then over here, we can also choose our pitch breaks and where do we want to place our vertical members, either on pitch breaks or supports, or if we have additional point loads, if we want to place them at point loads as well. This is the important part here, where what is your spacing between your webs? I'm going to say 4 feet for these. Okay, and then we can go on to the next option. So member sizes. So in member sizes, I can actually pick the sizes that I want to use. But before I do that, if I want to engineer this truss, before I am planning to engineer this truss, I need to go to general and make sure engineering only is checked on. Then it actually filters my sizes over here. So there's no longer those 162 sizes anymore. It's actually all 175 and up. Okay, so if the size is not available for engineering, you can get in touch with us and we can try to add that in for you. But in most cases, we've covered majority of the sizes, and we can control what we want to see in here and what we don't. So for the trusses, I can actually come in here and say, you know what, I'm actually going to be building everything to be either 400 or 600. So I'm going to delete everything up here. And then I'm going to go ahead and delete, maybe I don't want the 162s. I only want the 200s. I can delete the 400 S162s. You have to make sure that you load in your families prior to even coming into this step. Otherwise, they will not show up on the list. Okay? And I don't want to use any 500 or 550 sizes, so I can go ahead and just delete those. For the 600s, I don't want to use 600S 162s. I want to use the 200s. Let's go ahead and delete those. And then after this, I can get rid of the 8-inch ones as well and the 1200 ones as well. I don't want to use any of those. Now that I've consolidated my list to the things that I might actually use, 600S 250, 600S 200, and so on and so forth, I can choose to apply to all. And now this list is applied to all. So what I wanted to test is, I want to test if this 600S 200-68 is going to work for all members. So what I'm going to do is take that and I'm going to send to top, and it's going to test that size first. And if that size doesn't work for all members, if you just hit analyze, it's actually if it fails, you can actually go and design your truss, and it will basically go down the list and see which members will work for which portions of the truss. Okay. And if I want a capped member, if I check this on, it will only show me the 2 options that we have for capped members. If I uncheck that, then it shows me everything that we have kept in this list. Okay. Then we have the same thing for bottom chord. I want to kind of use this same schedule for all of them. So I'll go ahead and say apply to all. And now when I go to bottom chord, you'll see the 600S 200-68 is at the top. But for the webbing, we also have an option to create a half brace or create a 1/3 brace. So I can actually select that 600S 200-68 and say, you know what, I want to create a half brace. And I want you to test if the half brace works first. And if that doesn't work, then we'll come up with another solution. Okay. You can do the same thing for heels. I'm not going to apply to all because these guys, like the top chord and bottom chord, don't have the half bracing. So I'm going to ignore that. And then over here, we can go into physical member, set up our options here. So our top insertion width, bottom track insertion width, and then our pitch break. So do we want it to be open or lapped? So that's basically the tip of our roof, like that. What do we want that connection to look like? And then what is our chord end cut? So if it's in or out. So at the edge of the panel here, is it going to be in by using the center point, the interior edge and the exterior face of the roof? Or is it going to be out by placing the exterior or the shortest edge of the member to the outer face of the roof? That way it'll extend out and it can be chopped out. So that way it just adds an additional length a little bit, and your bill of materials will be correct that way as well. Okay? Well, it'll be correct either way. It's just depending on how you want the connection to show. Then we have our webbing. If you want to add extra length, if not square, or extra spacing between webs, you can specify those values here. Then there is effective length parameters for top chord and bottom chord. This is currently set to auto. If you want to modify them, you can uncheck that and specify the values yourself. If not, you can leave it at auto. And then over here, you have development length for brace. You can specify how many inches you want that dev length to be. And then over here, you can choose a wall truss if it's sheathed. They're LY for top chord and bottom chord. So right now it's set to 12 inches. Over here in the designer preferences, this is basically just to identify the node size in the truss designer once it opens up, and also your line detect as size as well. Okay, you can choose to show rulers, origin, and and to create a truss label as well. For engineering, we have a few options. So over here, you'll notice that there's spacing. This is very important for you to modify. In this case, our spacing is technically 2 feet, so we can leave it at 2 feet, but it is important for you to modify because the software will not detect if there is another truss nearby and what spacing it is at. So it might just be a girder truss or it might be a corner truss. There's no real truss nearby, so you actually have to set this up properly in order for it to be able to calculate the true loads of your of the roof on that member. So I'm going to change this to 10 and change this to 10 and change that to 10. And that's going to be my loading for this roof. Okay. If I go to general, you'll be able to see that I have these two building codes available. So I have AISI 2016 ASD or AISI 2016 LRFD. Okay, so I can use those and then I can choose how I want to design my top chord and my bottom chord. If I design my bottom chord as whole, my top chord is actually technically separated, so I can set it up that way. If I want to modify my CSI limits, I can go ahead and do that here. And then I can choose which analog model do I want, fully rigid or rigid and pinned. This is important because your supports, one of them needs to be roll and the other one needs to be pinned. Okay. So then over here, you can choose your screw size. So number 12, I'll say that I want 2 of them minimum screws for every connection. And if I wanted to be an even number or odd number, I can choose that setting over here. So I'll uncheck that. Actually, I'll check that on so it's even number for every member. Okay, we'll hit OK. And then if you wanted to see your wind loads and the wind load building code, it's over here. So if I wanted to design using ASCE 7-16, this is what I can do. I can come here and put in whatever values I want. We can hit OK. You can also take a look at the combinations. You'll see that all of these combinations are showing up. The more loads you add, the more combinations will show up, at least from my experience. And then over here, we can go ahead into reports, and it will ask you what reports do you want to print. We have a detailed engineering report. We have an engineering report, engineering drawing, and then we have a fabrication report. Okay, so I can specify everything like my name, company name. I'll basically put it in as StrucSoft Solutions. And then for the address, I can say 123 StrucSoft Way. And then for the city, I'm just going to put it in Montreal. UEBC. I'll just say 1, 2, 3, 4, 5, 6. And then country is Canada. Contact will be Aperna. And then phone number will be 999-999-999. Okay, for the email address, we can just say MWF support at StrucSoftSolutions.com. Okay, so now that we've set all of this up, you have 3 options here. You have the interactive view, which is your Truss Designer. You can choose to web on launch, so the minute the Truss Designer opens, it'll automatically have a web on it on the roof. And then if you don't want that, you can uncheck it. And then the third option is replicate identical. So what that means is if there are any trusses that are exactly the same, it will actually replicate that. And we'll go ahead and hit OK. And then over here, you'll notice that the Truss Designer gets opened up. So what I can do is I just have to double check if this node is set to either rolled or pinned. So this one's set to roll, so the next one has to be set to pinned. Pinned. There you go. Perfect. So that's done, and now we can go ahead and analyze this roof. Takes a little second here. So once we run the analysis, we can basically see whether it has passed or not. So it has actually passed. If it would have failed, I can basically get the engineer to take a look at the report. So after it passes, I can go ahead and generate the report, or even if it fails, I can generate the report. So it generates the 3 reports that we discussed: the detailed engineering, the engineering, and the fabrication report. Okay, so once we finish that, we can come here and I'll show you the reports. So this is what the report looks like, and you'll notice that all the information we filled out, it shows up over here. So for this one, this is our engineering report, And over here, you can actually see all of the little braces in red. You can see the circles, those are the screws. And basically for loading purposes, or if you wanted to submit this document to the city, it tells you that this is the code that it has been designed with. Okay, so that's that. And then over here, you can kind of take a look and see all the weights or loads at every single member. Then you have your detailed engineering, and this one basically tells you um, what's the vertical reaction and fun things like that. Again, it tells you what code it's been designed with here. Then you have the fabrication report. So fabrication report is basically how do I connect the two objects together? So they have come up with a solution to basically say now when this member connects to this member, it's going to be 2. When this member connects to this member, it's going to be 2, and it's going to be 2 on the other side as well. Okay, so over here you can see the web between 1 and 6. This is the size, and then it says this is the length that it was supposed to be cut at. The screws in the beginning is 6 inches. The screws at the end is 6 inches. Okay, we'll hit OK here. And once we hit OK, you'll notice that it'll actually create the same truss and the same profiles for all the other trusses behind it. Okay, once it does that, we can go ahead and keep building our trusses as we go along. Or we can also choose, I'm just going to quickly save this project. We can also choose to place or apply a preset to these trusses over here, and it will actually use that preset to create those trusses. Okay, and we'll come back to you. So over here, we'll go ahead and select Truss Manager. And basically in Truss Manager, it tells me which trusses have been built. So you'll see that the T001 has been built, and there's 5 of them. So it doesn't let me choose the offsets because all 4 items have been done for this. So what I can do is I can actually select each and every one. So I can create a new preset, or I can kind of use the existing one that I've already created. So what I can do here is I can actually come in and sorry, give me a second. Over here, I can come in after I do this. I can take a look at my member sizes. Doesn't seem to have saved. Okay, that's fine. So what we can do is go back into this truss, unlock the truss. We can go into properties. We can go ahead into settings. We can save file, save it over top of this. Once we do that, we can hit cancel here, and we can undo the unlocking of the trusses. And we can basically go into our presets. We can say load file and load the file that we had earlier. Just double checking all the members and all that fun stuff. Even the webbing with the half brace. Yep, that's good. We'll go ahead and hit save. And we'll call it Truss Presets. Hit OK. And once you finish that, you can actually load the preset over here and hit OK. So nothing really happens over here, but if I go to Truss Manager now, I can actually choose that preset for all of these and choose to get them framed. Okay, so I'll start with those 4 first, and I can go ahead and hit create with the first button here. And the best part is when you click on the trusses in the Truss Manager, it'll actually take you to that envelope, so you can actually take a look at, see what is happening there. All right. You may get this warning of beam or brace slightly off axis, which is totally fine. It's because the back-to-back truss, they need to align a certain way, so it might be because one of the envelopes is a little wonky, but that's totally fine. And then once we finish that, you'll notice that it's not been analyzed, so we can go ahead and try to get that analyzed by hitting the Analyze and Create Reports. So you may notice some errors like so because it says the truss cannot be analyzed because it has unknown load transfers. That might be because of these connections here. We might have to analyze the trusses that are being supported first in order for it to know what point load it has to have at that truss connection. Okay, so we can go ahead and close out of there. It's probably the SJ001. That's what's causing the little issue for that. So you'll notice that the SJ001, it actually was able to create the truss, analyze and pass it and create a report for it. For these two, however, since these are supporting more of these trusses, it needs us to create these trusses and pass them first in order for it to know what load is being applied at that connection and at that point in order for it to analyze these trusses later on. Okay, so you can keep going through here and you can keep keeping track of the reports. By default, the reports are being saved in CTemp. If you would like to change it, you can go ahead and browse and change it to a new location. And that way it will reset this report list and you will be able to see which trusses have reports created for them. Okay. That's pretty much it for this webinar. If you have any questions, feel free to send us an email at mwfsupport@strucsoftSolutions.com. And if you have any questions, we'll take some questions now.